The only problem with summer is it
All
takes a
right, I
long
think
time for
we're
it to
on,
get dark.
gentlemen.
Okay, go. You're on
I
the air.
hate to interrupt your exciting speech. We just love getting together and jabbering like a bunch of hens at a party in their back there. Good morning. We're back. Proud host of your SBAU Astro Hour. My name's Ronnie Heron. We're the planetary pack that meets on screen on Zoom every Monday for Santa Barbara, California's longtime telescope and astronomy club. And doggone it, if we have a lot of stuff to talk about this week. This is program number 234, well into our fifth year of doing these Monday morning get-togethers. Our summer skies are at a zenith, highlighted by the summer triangle. What's a stellar association anyway? We're going to find out this hour. Saturn's Titan moon going to cast its shadow on the planet a second time. Planet Mercury stretches its wings. Our moon, what's left of it, is about to pass close by a very gibbous Venus. And it's time to check in with our current comet in the sky, C2024 E1, now in Hercules. A lot of photos this week. Some pictures will include, get this, a view of the perceived universe as back in 1922 versus the vast cosmos we see and know today in 2025. Welcome aboard. Check us out online at sbau.org or go to the Santa Barbara Museum of Natural History. We're 3 weeks away from our Friday night first party meeting in September, and that'll be September 5th with Ish Call, a young grad student out at UCSB, regaling us with this topic, I guess, galactic rainfall and atmospheres. Let's meet the crew of the Starship Astro Hour, our commander. It's Jerry Wilson. He happens to be the president. And
Good
he's
morning, everybody, and good morning, Joyce and Riley and Calvin, my grandkids.
Are they watching?
Yeah, yes, I believe
It's a
so.
requirement.
Yes,
Okay, well, I hope they, as along with Tessa, our secretary, got the talking points sent to them because you guys on the screen, I've read all your homework there and we're ready to talk about these things. And your wife, Pat Forgy, she's probably not far from you right now, right?
No, she's downstairs. We're waiting for the cleaning lady. It's
And the dogs and cats are
that
getting
day.
along. They're not going to interrupt. Okay, well, that's our commander-in-chief of the Starship. Co-pilot and Captain Outreach is Chuck McPartland, right there in front of the Ukraine flag. Today's kind of a big day for Ukraine. We'll see how that works out. His wife, Pat, is also indispensable to us, both our club's merchandise manager and our treasurer. And the cats in the background, you'll see from time to time at Chuck's house. He's allergic to them. So if Chuck disappears from the screen, we'll understand why. Here's our science officer on board the ship, Tom Whittemore,
Morning.
former science instructor out at Westmont, editor of our monthly. We should do a weekly newsletter, shouldn't we, Tom?
No.
You've been too busy baking bread. He's married to his wife, Maureen, all these years. She used to take my blood out at the anticoagulation clinic. Navigator on board is Tim Crawford, resident lens expert, longtime member, and token fisherman of the
I'll
club.
give you a quarter wave.
Okay. Just don't take him fishing with you because he's bad luck. You'll never catch him.
No lie.
That's right. His wife is Karen. And get this, first mate and onboard Vulcan. Notice closely, Bruce Murdoch has pointed ears. And he's also president of the Santa Barbara Theater Organ Society, a longtime member, a very intelligent man, occasionally my mentor. Gentlemen, we always start the hour with Jerry's forwarded silly science cartoons and some incredible thought provokers. We got 7 mailed to us all at one time. If they're in a row, we'll be able to match my thoughts with yours and might even let some of you do some of these. But for the benefit of the folks, oh, here we go. This is Thag Anderson. Remember him? He invented the wheel and then became the first victim of the wheel.
Good.
He became a shish kebab for a saber-toothed tiger back how many hundreds of thousands of years ago?
Thag is a character in the Larson cartoon strips that
Really?
is
Thag?
their standard caveman. And one time there was a cartoon that showed a group lecture of cavemen, and they're showing a picture of the four spikes on the tail of a stegosaurus. And they were naming it a thagomizer in honor of the late Thag Anderson.
Yeah.
Well, that
And
Anderson crowd.
that in paleontology, that has become a standard name for that part of the animal now.
You suppose he had enough cartoons to fill a whole book of just Thag Anderson?
I don't know, he's got a lot.
I'll bet he did. Those Andersons, they do go back. I fell in love with an Anderson once. Uh-oh. This is tough astrophysics guys. It's a whole gang of them monopolizing the telescope time. I've often wondered about this. Intimidation and corruption of theoretical thugs. Cosmic
There's something
corruption.
wrong with this picture, by the way.
There's
Say
what?
again?
There's something wrong with this picture.
Is it washed out? Well, can you make them larger?
No, it says all day long, and if you look up at the corner in the picture, you see the night sky.
Well, that's how it used to be, I guess.
They're doing a 24-hour day.
Yeah, that's a little nitpicky there.
I love that eyepiece.
Oh,
Good
yeah.
observation.
Is there a place online where you can learn what they charge per hour for the Webb, for the Hubble, for the Vera Rubin?
Yes.
It's got to be thousands of dollars, wouldn't it?
Oh, it's a lot.
I can imagine. Well, I've wondered about now. This is relative sizes of proton, neutron. They're kind of like Earth and Venus sisters. However, the neutron, I understand, is the proton and the electron together. Then the
Correct.
electron gets even smaller, and it's not even matter, is it? It's more like energy. But nothing is smaller than the close the ad, please button on your screen. I got to tell you, along with stop my account, cancel.
Oh, you can't find the stop my account one.
I know that they don't even post those. Unsubscribe. Where the hell is that one? Evolution of photo storage. This is a good one. The Kodak cartridge. Where did that go? Floppy disks, CDs. Am I correct in
Yeah.
that? Or DVDs and thumb drives, and then whoa, up in the cloud. Where the hell is the cloud? Okay, this is Crazy Bob. I'm glad he's not in our club. The man loved outdoors or the outdoors. Wound up with quite a collection. This one exit. Here's one off of an outhouse. He stores them in his smelly room. Little play on words, friends, from the Jerry collection. Here is a thought provoker. My wife told me to take the spider out instead of killing him. So went out, had a few drinks. Nice guy. He's a web designer. We're friends now.
Web designer.
You know, you're never more than 6 feet away from a spider, I understand. I've read that they're
I
always
think at my place it's more than a foot and a half.
probably, yeah. Now this one interested me because I'm a radio guy. Sirius the dog star. Is it 9 miles a second? It's heading right at us. My God, moving closer to Earth at that rate, 9 miles. Means someday we could be in serious trouble. Isn't that where we get our radio program? It's a binary. Well, it's
Sirius radio.
Sirius and XM. It's binary partner. Never mind. Shut up. They were once told not to merge, and they did merge, and now most of the nation's hooked up to it. You guys are probably getting it on your Teslas, aren't you?
No.
You're not?
It's an option, but we've never used it.
I got it on my car
I-
too. Yep.
iPod hooked up to it.
Uh-huh. And they keep sending ads. Subscribe, and you got to turn them down.
Yes.
Okay, there's our center of the galaxy. We're starting the show, gang. Look at
Yep.
this.
This is the summer Milky Way overhead in the evenings. And it's prominent with the summer triangle here.
Yeah.
Really, it's superimposed right over that big long blur.
Blur? Is it blurry?
No,
no,
no, it's
No,
fine.
no. It's
What do
fine.
you what do you call that? That's just the side of that's our
The Milky Way.
yeah, it's
the Great
edge
Rib.
on. Right.
Yeah, it's a very pretty sight. A
And
lot
this
of light around the horizon, probably from neighboring cities.
Now, I was told it's like it was like having two plates together and you're looking through the edge.
But you know where the
No,
center
no,
is?
no, Tim, that's not a looking through. Those are clouds that are blocking your view further on.
But it is
Yeah.
like two plates together. We are looking at an edge of the Milky Way.
Yes.
Yeah.
Well, we're in the whites of the egg.
Do we know where Sag A is?
Yeah.
Well, that'd be right down there near the glow.
Oh,
Sagittarius A star.
at the bottom, just above
Yeah.
the horizon. Ah, that's the center.
So the teapot is also buried in that light pollution.
Yeah, it's hard to pick that out because they got so many damn stars in it.
You ought to go out to the desert. I'm sure you have. You know, when I align my scope, it's hard to tell which star they're talking about.
Yeah.
There's so many of them.
I was once setting up my scope up at Lake San Antonio, and I looked up and I thought, oh, I thought it was going to be clear, but there's clouds forming. Then I realized it was the Milky Way.
That happened to me up at Refugio, and also up at the gun club. I couldn't find Cassiopeia. I couldn't find it.
It was so nice at Kachuma on Saturday night.
Yeah.
When the clouds started coming in, they looked dark.
Oh,
black.
Interesting.
Blocking things out.
You know, Saturn finally rose high enough that it was quite visible, and that lasted what, maybe 5 or 10 minutes, and then the black cloud came in.
Oh, yeah. Kachuma fog.
So
Yeah.
this is the
Yeah.
summer. This is referred to as the summer sky, and it's at the zenith late in the evening, so it's perfect time for it.
Yeah, but we're not going to see that many stars.
Not down here.
No.
There is a let's see what the am I talking points of here?
I was a little confused in the talking points when they started talking about the relative positions of Vega, Deneb, and Altair until I realized they were talking about it being past the zenith already. You know, when they said down and left and up and right and things like that. North, south, east, west was right, but the others were confusing at first.
Well, isn't Vega the top one here, and then Altair to the right?
No,
No, that's Deneb.
yeah, there's Deneb, and then Vegas to the right, and then Altair is down below.
Oh, that's
Altair's got
weird.
its 2 wingmen here.
Yeah.
Oh.
Okay, so anyway, up in here also is an NGC. So there's a star. Okay, let's go to the next one. In this region, there is a star. This is the Cygnus, the Swan, which is in that collection you just saw. That was a very deep photograph. This is a planetarium software, and it's NGC 6910. It's not this star here, which is Sadr, S-A-D-R. It's right next to Sadr, right in here. And that is, according to the Sky X, this is a blow up of that. This is Sadr. And
Sadr,
this,
S-A-D-R, that does sound Arabic.
okay,
Yeah, breast means
and
breast.
this is 6910, NGC 6910. Now this is a called an association. And
Yeah,
an
Jerry,
association-
I've shown that a lot at Westmont. That's a beautiful open cluster. 6910 is really pretty
yeah.
in an 8-inch. Yeah.
That's a
Can you see
cluster.
all that white stuff, all the illumination there?
No, well, not in the 8-inch. No, that's
This
That's
is just
photographic.
a graphic representation of the nebulosity around here, and it's only loosely what it actually looks like.
Huh.
So
Wow.
we have much better charts based on photographs of the Butterfly Nebula, which is
Oh,
this part of
that's
it.
what it's called.
And down in here is the Crescent Nebula, which I've photographed many times. The Veil Nebula is over here, showing a lot of the, and in a small refractor, you can get the entire thing. This is actually a big loop of things from a supernova that was in here one time, and it's a long time ago. It's the ring of debris is blown way out. But you can get these all in the same field of view, and it's quite dramatic.
Well, if we got a
Now,
close,
up here,
if we got a close up of the crescent, would it be crescent shaped?
it depends. If you look at it with a short exposure, it looks crescent shaped. If
Okay.
you look at it with a long exposure, it looks more like a kidney.
Yeah.
Kidding me?
It's often called Van Gogh's ear too.
Okay, yeah, that's right, yeah.
A really good star hop to get to the Vale is you use Deneb and go through, is that Epsilon Cygni?
Yeah.
Mhm.
And so you go right through Deneb and Epsilon Cygni, and there's a real faint star down below that's dead smack in the middle of, it's called 52 Cygni. It's dead smack in the middle of the Witch's Broom, which is
Yeah,
that
it's this
lower
little
section.
bright star you can see right there.
That's it.
Witch's broom? What's
Yeah.
that?
That's part of the Vale Nebula.
Okay,
See, this
it's
thing looks like kind of a broom.
It's a crooked broom.
The witch triangle going this way. And
So
then
we have-
it's 52 Cygni.
Yeah.
we have a broom up there, but no witch, as far as we know. And
No, there's a Witch Head Nebula too.
Mhm.
But that's in the winter. That's in the wintertime.
Right.
okay, good.
That's near Orion.
Good. I hope it's
So-
available at Halloween. Go ahead.
We know that stars form out of nebulas. There's things like the M52 in Orion, M42 in Orion, the Great Nebula. Stars form out of the gas and dust, and they form basically a star cluster. But what we're going to talk about here is associations, because those are like a star cluster. But the star cluster has two types of stars in it when it first forms. It has big stars that burn hot and have short lives, a few million years. And then it has a lot of smaller stars like our sun that last billions of years or even longer. And so these are called OB associations because the spectral type O and B are the hot young stars that don't last long. So when the star cluster forms, it's actually called an association with those hot young stars, and then they die off and you get the classic star cluster.
Huh. Wow.
Jerry, in that butterfly nebula in an amateur scope with a filter, could you see that?
Yeah,
Oh,
Okay.
easily.
if
Okay.
you have a big scope, yeah.
That's
Not
it.
gonna be a
That's
2-inch
supposed to be a
diameter scope.
butterfly. Okay. Wow.
Yeah, all this is available on a real dark sky. You can even see the North American Nebula. It's faint, it's very diffuse, it's big.
Yeah.
But these things are frequently made out of hydrogen. And the hydrogen, you can look at it with a hydrogen alpha filter, just like you do with the sun, although don't use a solar telescope. But this one, you can look at it and even in light polluted skies where you can't see this, the filter will bring these features out. They'll enhance the Pelican Nebula, for example, and the North American Nebula.
Well,
So
I
you-
didn't know that.
You can
I
take
thought
a
I had,
long exposure light. You can't see it visually, but you can take a long exposure with a narrow band filter and you can see that you can get a good image of it.
okay.
How people take advantage or take that Tarzan there. So it's how people take deep sky photographs from downtown Boston, for example.
Downtown Boston or Austin? What did you say?
Either one.
EOSTON.
Yeah, Robert Gendler, he took pictures right in his neighborhood with the
Yeah,
with
he
his
lives
gear.
in Connecticut, I believe.
Yeah.
Try doing
Connecticut.
that in
You're right.
Chicago.
Does
Yeah.
look like a butterfly.
Try
Okay,
doing
this
that in Chicago.
You could.
When we were visiting there and you look at the night sky, it's orange, all of it.
Oh, there it is. Okay.
Here
Oh.
is the association, the singing group from the 60s. So NGC 6910. And this is what's called an OB association because it has O stars in it and B stars. And those are all young, hot, giant stars. They burn hard, they're bright, and they don't last long. So a stellar association, this was developed in the 40s, is a very loose star cluster. That is, it's open. It's the stars share a common origin. That is, they came from a cloud and they're still forming together. They're still moving together through space. They're still gravitationally bound to each other. The star cluster our sun came from is not gravitationally bound to itself. They've gone around the center of the galaxy a couple of times, and so each one is in a different orbit. So we've all dispersed from our cluster.
You're saying
What?
our sun was in one?
Say what?
You're saying the sun, our solar sun, was in a cluster?
All stars started with a cluster.
Oh, I thought we captured them. They were like mini galaxies going around our.
Well,
Okay.
you can do that too, but it's hard to capture something.
Ron, you're thinking of globular clusters. That's not what we're talking about here.
Yeah.
Star clusters, globulars are totally different things. But
No, a globular cluster is a star cluster, but it's a different kind of star cluster.
This is a very loose star cluster. Read this as opposite of a globular cluster.
so they're pretty well born in any big nebula that's a nursery has something like this going on in it, wouldn't you think?
That is correct, yes.
Aha.
But they become gravitationally unbound, as they all will. Associations are primarily identified by their common movement vector and ages. So you look at the composition of the stars, you look at where they land on the, what is that?
Hertzsprung-Russell.
Thank you, diagram. And they have common velocity vectors, and they're about the same age. So that would be an association. This one's by chemical composition in association membership. So this is one of the largest associations. This is
Wow.
the
Wow.
Carina OB1, which is a large OB association.
I missed this in the talking points, or it's just on my new computer because it looks really good.
This is a photograph I changed between when I sent you the picture and when we're looking at it now, because this is a better picture of an association.
Really pretty.
It's kind of blown out in my view here, but
Okay.
The middle is blown out, but
yeah.
whatever.
Boy, I don't know how you get it any better. It's neat.
But it's got both blood types O and B,
Uh,
Yeah.
Yeah.
I took one just like that with my iPhone the other night.
Yeah, it's near a star temp called Kenobi.
Well, Obi-Wan to you.
Is this better?
That's better.
Mhm.
Okay.
Looks like
Still a lot of white in the middle, huh?
Yeah.
Mhm.
Okay, sorry.
looks like one of those undersea creatures in the Abyss movie.
Oh, I like the undersea creatures in what is it? One of the Star Wars things where it had that alien that nobody liked.
Oh yeah, right.
So these O-class stars are short-lived. They will expire as supernova in roughly 1 million years, so they don't last long. As a result, OB associations are generally only a few million years in age or less. OB stars in the association, that's O and B stars in the association, will have burned all their fuel within 10 million years. And you can compare this to the current age of our sun, which is about 5 billion years. So all the OB stars from our cluster are gone.
Really?
Now, this is a map of the nearest OB associations within 1,250 parsecs. A parsec is about 3 light years. So here we are at the sun. This is the Scorpius OB2 association, Orion OB1. So these are like brand new star clusters.
Where's that Obi-Wan Kenobi?
He's out fighting the Sith.
Okay.
I want to see the Princess Leia.
So anyway, I don't see the Carina one. It must be farther away than
I
that.
thought I just saw it. maybe I'm wrong.
There's Era, that's down south, so maybe it's off the bottom. Vila is down there. Cercinus,
There's an
Era.
Obi-Wan star over on the right-hand side, about 4
Obi-Wan is
o'clock.
an association. There's no such thing as an OB star.
I understand. I mean, the label here on your
Yeah.
diagram.
Yeah, there's an OB1A there.
Huh.
Well, that's close. Obi-Wan.
Yeah,
Yeah.
There's also an OB7 and an OB3 and another Obi-Wan in the middle there.
I'm sorry, I may miss something. Are these all nebulae or is it one big nebula we're looking at? These
transitions to very young star clusters from nebulae. They're probably going to still have gas around them, like M35.
But normally we can see these stars in our telescopes, but not the nebula around them.
No?
It
You can see
depends.
what we showed earlier, the butterfly nebula and stuff. Those are, you can see all that stuff.
Really?
It depends on how close the gas is to the star, whether it's fluorescing brightly enough to see.
Right.
So that
There's
would be
the
a big
butterfly
spot.
right there.
Well, actually, the
Gotcha.
butterfly's that whole big thing above it.
Does Sadr mean butterfly in Arabic?
No,
No.
it's breast.
Then
What?
what's this little thing down there?
That's Sharpless 2108, so that's
Okay.
a little.
Yeah, I guess this is an overexposed butterfly.
Well, that's one wing. You don't have it quite all in there. If you come down a
Yeah.
little more, maybe it'll show. Yeah.
That's one wing, huh? It's in honor of our exhibit at the museum.
Oh, there it is up there.
Yeah.
Wing 1, wing 2. You're right.
So they're separate. That's not just gas in the middle, gas and dust.
It is.
It is gas and dust. I thought I'm seeing stars in it between. Okay, let's go to other parts here.
Now
Negative,
this one,
reverse,
what's
Yeah.
that?
reverse
A
negative.
negative view.
Yes, that's right. The white is black here, or black is white.
You,
Capella, a lot
uh,
of famous stars, Vega. So there's Deneb. I don't think Sadr is necessarily, that might
Yeah,
be
solder's
Sadr.
just to the right of it. Yeah, there it
Yeah,
is.
there, yeah. So, and these are the major associations, the OB associations in the plane of our galaxy, visible from Earth. Scorpius Centaurus is a humongous association, I suspect, because it's very close. So,
On the next spiral arm inward.
okay. Yes, there'll be stuff on the other side of the galaxy that we would only see if the galaxy became transparent. And so all that stuff is missing. We just show the stuff on our side.
A fascinating galaxy we have.
It's
Canopus is there at the very bottom of the bottom image. There it is. There you go, Tim.
Canopus.
Tim's gone somewhere.
I'm here.
Okay.
Ran out of coffee.
Okay. And here's Orion over here. I
Yeah.
believe that's Orion.
Mhm.
Yep.
Yeah. And Sirius. We could be in trouble someday.
Yeah.
Your scientists like to look at it this way, reverse negative, rather than white spots on a black background. What's your favorite?
When I looked at a lot of astrophysical journals, in the journals they would show the nebula photographs as negative images because it was easier to see faint, dark, thin, wispy things against a white background than it was to see white
Little
things
white.
against a black background. So it was sort of style then, but I haven't looked recently to know if they do that. I know most of what I see nowadays are data and not photographs.
And it used to be that people were looking, when they were studying all this stuff, they were looking at photographic plates that were negatives.
yeah,
Yeah.
right.
So
Oh,
it's
yeah.
kind of a tradition.
That's not done now with the digital revolution in play?
No.
Doesn't you? Okay.
I mean, you can do
And
it
you can
easily.
push
You just,
Control I and get it, but
Yeah,
You'd think they'd have all that silver left over from the Kodachrome generation available for coins again.
well, I'm sure they extract the silver out of the leavings. They
I
don't
know,
throw it away.
but what didn't they just ferret it right back into the photographic industry back in the 80s and the 70s? And
Right, right.
I remember hearing that it would never change, that it needed silver.
yeah.
Yeah.
The photoreceptor was a silver halide molecule.
Is that what
Wow.
it is? Okay.
Yeah.
Somebody's got a lot of silver somewhere.
There was
There,
some
if you wanted
group
to
of
have
people,
a
I think the
high
Koch
ISO,
brothers
you
that
had
tried
to,
to corner silver.
All right, somebody repeat that. President Jerry?
Yeah, back in the 70s, I think the Koch brothers tried to corner the silver market by buying up
oh
all the
yeah, yes,
silver.
yes.
They didn't succeed and they lost a scat of money.
Really?
Good.
Would that if they could have done it, would it have driven up the cost of pictures like crazy?
I don't
Photographs?
know.
Huh.
if they had
But
any
the
say in
study-
it, it would
Warehouse
have.
with big piles of big stacks of silver ingots in it, and they were gonna, when the price gone up and up and up, I think they were gonna sell them and make a lot of money.
Hmm. Well, I wonder if the new digital came along with Wozniak and
No,
Steve Jobs and all. Did they invent any of that? That's what somebody
no.
else didn't have anything to do with it.
They put chips together to make a home computer. That's what they
Yeah.
were.
Yeah.
Okay.
I wish Kodak would come back.
Kodak.
That was the start of Apple.
You can still get film if you want to do it, if you want to shoot on film. A lot of artists like the tone qualities of pictures on film, especially black and white film.
Black and white. Black and white.
Ilford still makes 35 millimeter film. And I think Kodak is just getting out of that business.
It's
still got-
expensive to get it processed though.
Yeah.
Not if you do it yourself. You just have the chemicals. It's only 3 chemicals. You have to do it in the
Really?
dark. So
And
Well, I
Kodak
did that
is,
when I was in high school. I was the photography commissioner, but that was a 4x5 speed graphic, and it was black and white.
yeah, I like black and white. I took a class in printmaking from an artist in LA in the 70s. Very much fun.
But are you saying that with the advent of this new digital, that dark room and all those chemicals is gone too? We
No,
don't have
it's if you want to do it, there are people that still use the old daguerreotype process, sepia tone prints, because they like the quality of them. They like the warmth and the tones and stuff.
Oh,
So-
nice.
Artists, the processes are simple, straightforward, well documented.
Ansel Adams.
Yeah.
fascinating.
Yeah, I used to develop all my own film. Never sent it
Really?
out.
Wow.
Yeah.
Cool, Jerry.
Black and white film, I assume.
What a group we
Yep.
have.
So did I. Yep.
Okay, so
Because when you
this
develop
is,
color film, you've got to go. I forget all the tests, but you actually have to re-expose it to reverse the image
who's that?
before
What?
you're finally done.
Start that over again. What are you saying, Bruce?
With color film, it's
Oh,
a
yeah.
native color film. I'm slide film. I'm sorry. You have to do once you start the processing, you get to a point that you have to re-expose it to light, which causes it to reverse the
Right.
colors.
Yeah, for slides, you have to make it because it comes out a negative, you have to make it a positive.
Huh.
Right.
Wow, interesting.
But that's a different stuff.
Yes, it
So
is.
this
That's
is in the
complicated.
evening around 10:26 p.m. in the evening. This is looking east. Saturn and Neptune have just risen. You won't see Neptune with the naked eye. But, and you won't see these things too. These are just in my planetarium program.
But
And
you'll know Neptune is there.
what's that?
You'll know Neptune is there next to Saturn.
Yeah.
Just
And
can't
we
see
have
it.
to take a second and go back to the other one because this program thinks this is my last slide.
Uh-oh.
So just a moment.
I didn't realize that Saturn was rising this early.
yeah.
Yeah.
No, it was up. It was after 10 when it came up.
It rose at 9:38 on Saturday, and so by 10ish it was up high enough to see.
And
Yeah, that's what I should say. It came above the foliage.
Yeah,
just in time for the Kachuma fog.
yeah.
Yeah. So anyway, here we are back home again.
Okay.
And this is Saturn at the same time. Oh, no, this is August 19th, 4 a.m.
Well, that's 1 a.m. our time.
Yes.
Okay, what's going to happen to Saturn?
Nothing. It's just going to cruise along.
But
I
Titan
thought there was
Shadow,
something. I thought there was something involving a moon.
There
Yeah,
is
Titan
Titan
Shadow.
here and Titan's
Yep.
shadow.
Oh,
That's what's happening.
Now, this is toward the end of this effect where you can see the moon off the planet and you can see the shadow of the moon going across the planet. The planet has to be tipped just a certain way toward us in order for this effect to be. And this is one of the last ones of those that we've seen. They've been going on for about a month or a little over.
nice, Jerry. Those are nice.
So this again is not an actual photograph. This is from a planetarium program.
Yeah, Titan won't look that big relative to Saturn.
Right.
Live.
And remember, when you look at things that have different sizes, like stars, you are not looking at the star size, you are looking at the star brightness.
Uh-huh.
So brighter things turn out big.
And is it my understanding that Titan is a little further out than most of the stars, isn't it?
It's farther away from the planet than the rest of them.
Yeah. So it's on the inside between us and Saturn there?
Yes, close to that.
Okay. Got it.
Huh.
I'm going left to right.
Okay, now Mercury is at its near its maximum western elongation, so it's high in the morning sky. And here we see a map of Mercury's surface taken. That's what it will look like at 2 p.m. Pacific Daylight Time on August 20. What is today? August 18. So this will be Wednesday night or Wednesday afternoon at 2 p.m.
Actually, that doesn't jive with UTC.
Right.
Uh-oh.
How's that?
Well, that would be 6 a.m. our time if it's 1300 UTC.
Huh.
Something's weird
Really?
there.
Yeah. Oh no, something. Maybe I got a setting wrong in that software.
We're in time zone -8, so you take 8 off to 13.
Well,
Anyway,
but
you
we're
have
in
to add
daylight
hours.
saving time, so
I
you
know,
take
you have
off
to add
7.
an
Yeah.
Okay. Moving on.
Yeah, there was a beautiful alignment this morning of Venus and Jupiter and the moon.
Mm.
And then upper left, you would see Capella. Okay, it's off the screen here.
Yeah.
And the
And I've been
moon is
watching Venus for the last couple of weeks, Jerry, and last Monday, a week ago, Venus and Jupiter were side by side, and you could literally see morning after morning after morning, Venus just dropping down, dropping down, dropping down. It's really neat.
So this Wednesday morning at 3 a.m.,
Mhm.
the moon will be just passing through what is that? The Gemini twins.
Gemini. Mhm.
Yeah. And you can see it's a thin crescent here. It's a waning crescent.
Mhm.
Venus is down here. Mercury is as high as it's going to get in this sky. And it's up near the Beehive cluster,
Mhm.
M44.
Oh,
You can see a faint halo of lighter background around here. It's the planetarium software showing the brightness of the moon interfering with the darkness of the sky. So
even though it's a sliver.
even, well, it's a faint one. If this were a full moon, it would be much more bright.
When is new moon?
Dark.
I know, but when is it? This weekend or Friday or?
Yes, probably this
Pretty
weekend,
soon.
Friday or
The
something.
22nd.
Okay.
So that's
okay.
Friday.
Friday.
Fascinating.
Tim, what's the name of that star up there that begins with W?
What's that?
What's that? What's
Yeah, I
that?
used to tell people that, when I go looking for the Eskimo Nebula,
Mhm.
you have to go to that star called Wasatch. And I said, remember that old beer commercial where they used to go, "What's up?" And I said, well, this is Wasatch.
What's that? Well, what are we looking at, Mr. President? This looks important.
This is a published map of what I just showed from my software. This is my software planetarium program, 3 a.m. And you'll notice that the published one in Sky and Telescope, 1 hour before sunrise. Well, they are very persistent. So this is another mapping of it. I think this is from Stellarium, August 21 hour before sunrise. This is why I looked at it, and my program gives it as 3 a.m. But and it doesn't have sunrise at 4 a.m. So I don't know. Little difference there.
Yeah, sun comes up, it's about 6:30.
That's what I thought, yeah.
Trying to read those names, and I just can't get him even looking through glasses. They're still a blur.
Well,
Well, here's
Castor Pollux.
Castor and Pollux.
Mm-hmm.
There's Jupiter, the moon,
Oh.
Venus,
Mm-hmm.
Procyon, and Mercury, and Earth.
So the planets make a nice line.
Now, don't start that. They're still getting ads that said, go out in the evening as the planets are all in a line. Won't happen again for 1,000 years or something.
Mm.
Well, does anybody know in science when the planets are going to line up like they did when we launched the Voyagers to do the grand tour? They're all going to be on one side
Oh,
again.
exactly that. That wasn't specifically a line. That was just an opportunistic maze to go through, and they had the spacecraft zip from one to the other, but they weren't all in a line. I mean,
Yeah.
except that they're all in the ecliptic all the time.
Right.
So
they
Yeah,
weren't-
and that they did that. They had to account for the travel time between them, so it's not like they were all lined up.
right.
Well,
So
somebody
Ron-
asked.
Yeah,
Okay,
Ron,
go-
I think it's when the moon is in the 7th house.
Yeah.
And
Okay.
Jupiter aligns with Mars.
Mars. Peace will
It is
come to the
drawn
planet.
into the age of Aquarius.
You want to give us our horoscopes while you're at it there, Tom?
Well, you get a horoscope.
A horoscope becomes that, doesn't it, in the end
Yeah.
of the hour here? Fascinating stuff,
Well,
Mr. Trez.
Or our
Of
friend
course,
Astro
You
Deli
know,
is with us.
astrology is a very ancient thing. It's over thousands of years old. The
Mm-hmm.
sky has moved since then. I think it's moved by at least one whole zodiac sign. And there's a 13th zodiac sign now.
Yep.
But the old
Ophiuchus.
mysticism is still chugging along.
Our friend Astro Deli is with us again. He says September 7th, there's a lunar eclipse coming. I don't know if that's for us, though.
Not for us.
Yeah. Enjoy it.
What part of the year would Ophiuchus represent?
December.
Yeah. Chuck's
Well,
birthday.
That's already taken over by Capricorn, isn't it?
Nope.
No.
Nope.
No,
That's
Chuck's birthday.
Oh,
The
okay.
phrase from Neil deGrasse Tyson is, if you think you're a Sagittarius, you're probably an Ophiuchus.
yeah. It's Scorpius that it spends very little time in, and most of that time now is
Okay, if you think
Ophiuchus.
you're a Scorpius, you're
Yeah.
probably an Ophiuchus.
Okay.
Now, this guy,
Is another one of those really horrible star charts.
yes, yeah. But I didn't want to
That's-
transfer this line to, it takes a lot of time to get that in there.
But that word on the right is not boots, it's Boatus, right? Or Boatus,
Yeah.
Boatis.
the
Boatus.
Scandinavian name.
So in German, when you put an umlaut over something, we were taught to give it a slight R sound, Veritas.
Oh,
So I don't know if that's the same thing in Scandinavian, but a lot of those
Oh.
countries around there use umlauts.
Yeah, this isn't Scandinavian. This
No, not at all.
Well,
Then
it's
I have
not,
no idea what that is. or
That's
how
just to
pronounce
give it
it.
a syllable, Jerry. Bohotes.
I used
named
to,
after,
I'd pronounce it ooh.
isn't it named after some guy?
no,
Oh, it's not?
I
No.
think it's named after a cat.
Or
Yeah,
is,
yeah. The one that likes to perch on your shoulder, huh?
Yeah, right. So anyway, in Hercules, there's the famous M13, which is a beautiful globular cluster.
Right.
I understand that Chuck and Bruce were both showing that at Lake Kachuma last Saturday.
And Chuck showed it up at Westmont, Jerry.
Okay,
Yeah, it was beautiful in his scope.
Really?
this comet is not an easy comet to find and follow. It's around 15th magnitude right now. So it's
not easy to pronounce either, according to that name at the top.
I figured that's Polish, and I don't touch Polish. That's just
Okay.
Okay,
Tommy?
Tom should know though.
Tom will know it.
It's a weird spelling of a Polish name, but it'd be Wierzchość.
Veer
That
choice.
S with the little accent goes to an SH.
Wierszos.
Chość.
Okay.
Wierzchość.
Sounds like something you'd get with your beer at a Oktoberfest.
Gesundheit.
Yeah.
Yeah, what's up?
We had a engineer at Delco's whose name was Milos Makacek, Milos, and you pronounced it like it was SH
Is that
Right.
right?
on the end of yes.
Somehow they get the V's and W's interchangeable. I don't understand that at
Yeah,
all. They don't sound-
that would be a Hungarian. Milos.
I'll be damned.
So let's go back and forth with
Yeah, he was from Hungary. All right,
the
right.
two charts.
Yeah, that's Hungarian word.
Right.
But we don't have a picture of the comet?
No,
Oh,
I
we don't?
didn't find one. I didn't look very hard.
15th magnitude is really dim.
Yeah.
Oh, yeah, that's photographic stuff.
This is M13 here and 6058 there. And this is M13 here and
Mhm,
6058 here.
mhm.
So it's somewhere around in this region, but
Okay.
it's still in Hercules.
Huh.
It's what?
I'm just noting what you were pointing at. What's the square in the middle next to it? What is that known
The
as?
trapezoid, that's actually the keystone, Hercules, the keystone.
Mhm.
I didn't think it was a square. I haven't been drinking at all this morning, so.
Well, you better hurry and catch up.
Okay. Lord,
What is that called? A rhombus?
I think it
Yeah,
is.
it is.
Yeah, that'd be rhombus. Mhm.
I thought it was a trapezoid.
Yeah, maybe
Trapezoid.
trapezoid.
Really, right?
Trapezoid has
Trapezoids don't have to have any parallel lines in them, do they?
I think two sides have to be parallel in a trapezoid.
Well, then that's not a trapezoid because none of
Right.
the lines are parallel.
It would be a rhombus. You're right.
Yeah, okay, rhombus it is.
How did I remember that?
Nice dance.
Plenty of room for a rhombus.
Yeah, that's pretty good. A rhombus
It
room.
gives you a good way to spot M13 because you can easily spot this structure if there's not too many stars out. These stars are not the brightest in the sky.
Mhm.
So if there's a lot of stars out, I tend to lose this. But if you can find the trapezoid of the rhombus, then 1/3 of the way on this side
Mhm.
is M13.
And
Easy.
it's always the side of that of the keystone away from Vega.
Yeah,
Yeah.
the leading edge.
Yeah, and often people dismiss 92, which is a beautiful globular. It's a
I haven't, Tommy, I'm
Yeah.
guilty of not going there.
Oh, it's a wonderful. Of course, it's not the monster that 13 is, but it's really nice.
Yeah.
And of course, 13 has two galaxies hidden behind it. One
Right.
that's easy to find,
6207,
one
6207. Yeah, that's the easy one. The one way back there, you need an 18-inch to see it.
Yeah.
Huh.
Wow.
There was a guy who showed up at Westmont
Uh-huh.
that was asking, or it might have been Kachuma. He was asking about buying stars and naming them after people because he had a little chart of his star. And it's
Uh-oh.
right here, right near where Jerry's cursor is. It's right where the handle joins the bowl of the Little Dipper.
Uh-huh.
That star there, that was his star.
Huh.
And who
Pretty
gets
good.
the money for that and authorizes it?
There's like, it's not authorized at all. And there's like
Some
three
crook.
companies
Some
that do it.
crook.
Yeah, it's a scam. Totally.
So
Scams
Tim,
are us.
Tim,
All right.
on Friday, what was the star that you showed people?
Oh shoot, that's neat. La Superba.
Yeah, that was really pretty.
Superba?
La
Mhm.
Superba. And you go from one of the stars in the Big Dipper to
Mhm.
Corcaroli, about 2/3 of the way.
Yep.
Wow.
Really nice carbon star.
Hmm.
All right. You've changed the map, Mr. Prez.
That's a
We're up.
beautiful map.
Yeah,
That's kinda cool.
My eye
That's
caught
a-
this map on the internet, so I captured it.
That's a nice one, Jerry.
It shows NGC 6058 and it lists the star names. My software, the Sky 6 or the Sky X, I have one on each machine,
Mhm.
doesn't really, it's really arcane to get the labels the way I want them. But this chart has a lot of really nice labels.
Mhm.
So anyway, this is the cursor on 6058, and this is 6058. So
Mhm.
it's basically this cursor right here in the armpit of Hercules.
Mhm.
So the
That's his
circle
knee.
is
What's
the
that?
big,
That's
Is
his
the-
knee and his foot. He's the kneeler in the sky.
Right.
are we looking in the big circle at the blow up of what the red circle is?
Yes.
Oh, I see. Okay.
So this is the side where M13 is. M13 is not shown here, but this is the side where it is. Because as someone said, it's away from Vega. Vega's over here. So this is the side opposite it. And you go 1/3 of the way down there, and
That's it right there.
that feature
There it
right
is.
there is probably M13, although it's not labeled here. Just the stars are labeled. And these.
What's the way?
I don't know what PGC is.
It's a galactic catalog. So
It's
that's
really dim.
yeah.
Yeah.
Can you delineate what's the wavy white stuff on the left side of the photograph?
Oh,
is?
that's our Milky Way.
Oh, is
Yeah.
that the center? Okay.
Not
No,
the
it's not
center.
the
Not the
That's
center, just
Milky Way.
Milky Way. All that's big cloud of stars.
Milky Way goes all the way around the sky.
Mhm.
Okay. And what's the main, what do they call it?
The
The
Milky
slash?
Way.
Just the Milky Way. I know that, but there's something very predominant. It calls for a little simple name like everything else we give in astronomy, black holes, clusters. Why not just call it an asterisk or a slash or
There's star clouds that are not resolved.
that's not very
Ron,
simple.
the Romans called it Via Lactae, the
Which
way
means-
of the milk, like milk.
Yeah.
They saw it as
Yeah.
milk. Lactae.
I have to ask a question here, and it's going to sound dumb, but the letters, are
Mhm.
they Latin or Greek?
Greek.
They're Greek. Okay, thank you.
Is that
I've
Greek
never
to you,
been
Tim?
good at-
Symbols are the Greek alphabet.
Yeah, I've got to
They
go
have-
through that. I always want to
Yeah.
tell people you have to go to this.
Right. And
And I
Chuck
never-
is right, by the way, Tim. So that's the kneeler there. And so on the right there, upper structure, that's where he's kneeling.
Yeah.
Okay.
His head is Ras Al Gethi way down at the bottom.
Exactly.
So where-
And
where's the-
Ross means top.
That's where his head is. So that's where the club is, right?
The club is over by Cornephros there.
Yes, yes.
Not really showing much.
And so he hit the Boetes, the ice cream cone, and knocked off that extra scoop in Corona Borealis.
Yeah.
Right. Yeah.
Okay, you've been staring at the sky too long.
Okay. Sorry. This is a neat chart, Jerry.
Oh,
Yeah,
that's
I
a
like it too.
fabulous chart. And you can track where T Coronae is, but it hasn't burst yet that I can see.
No,
Although
but it's doing some wigglings.
yeah, it's been inching up.
Okay.
Is it over there by Epsilon?
Yeah.
Yeah, okay.
Mm-hmm.
And this is the summer sky we're looking at.
So there's 6058, Ron,
Oh,
right in the middle. Look at that thing.
Planetary?
Nebula.
Yeah, I've
So
never seen that. Have you, Chuck? You ever
No.
seen that? Yeah.
No. And it's a planetary, right, Jerry?
This would be a
Yeah,
Joe
a
thing.
planetary. It's small and it's faint.
Little Eskimo.
Yeah.
That's neat.
I don't know, it looks like an eyeball to me.
NGC 6058?
Hmm.
Yes.
Yeah, right up there at the top, it says NGC 6058.
Oh, okay. I'll go look for that.
6058. Okay, me too, me too, Bruce. I got
Yeah, big optic and a filter. Recommended.
Oh, wow.
What filter? Deep sky
Just
filter?
pop right out with a
Yeah,
filter.
OHC would work. UHC,
Okay.
sorry.
here we go. The comparison. 100+ years.
Yeah.
Love it. Just us back in 22, right? No other universe, just
That was a big debate at the time because they saw other spiral nebula, and they didn't know if they were spirals in our galaxy or they were other galaxies. And Hubble is the cleaning ladies passing by. So he saw a Cepheid variable in the Andromeda galaxy, and he measured the distance. It was clearly outside the Milky Way, millions of light years away. And so the universe took a big jump in that. And now with our finding of the microwave background, the redshifted microwave background, which is represented by this red circle around here, around the edge, no matter where you look in the sky, you see light from this microwave background that was emitted 13.8 billion years ago. So while that light, which is probably about here, so during the time that light was emitted and traveled to Earth, the universe has been expanding. And at this time, when the light from here is just reaching us, it's now out to a radius of about half of 93 billion, which is what, 47 billion, 46 and a half
billion.
expanded out to this thing. So this is the observable universe. It's physically possible to observe this, but you can't observe it because, and it's a really confusing set of terminology for that. Because if you look up in the sky, you certainly see this, but not as it is now. You see it as it was 13.8 billion years ago. But if we wait long enough, another 30 billion years, you'll be able to see it where it is now. But it will be, of course, way farther out than this.
And those two different measurements, the 13.8, if you say the distance is 13.8, that's called the look back time.
Right.
But the actual distance that it is now is called the co-moving time.
Yeah.
But how long have the light waves actually been moving? How many?
13.8 billion.
Mhm.
And in that time, it's expanded to 40 something
Yeah.
billion.
46, yeah.
And it's been emitting light too. It's just that that light hasn't reached us yet.
Mhm.
Huh.
And the expansion's accelerating, so eventually,
It will never reach us.
yeah.
Now, if you were able to see that perimeter out there, is
Which-
that
Which you can.
now that takes us back to an early universe?
Well, that's the surface of the fireball of the Big Bang that you're looking at,
Right.
the microwave
Which is
background.
about 300,000 years after the Big Bang.
Yeah.
Okay.
Does anybody know before we go where they pointed the Webb to get those 5 strange early galaxies at 300 million years?
They're up there and they're all over the place, but I don't know what their right ascension.
Yeah. And Ron, they've decided since then, and it was 6, that some of them are large black holes, supermassive black holes. So it's
Okay, regardless, but still, I'm wondering, what if they turned it 180 degrees and looked at the other side? Would they see the same 5 blobs, whatever they
No.
were?
Mm-mm.
no, they'd see similar things.
So there's an infinite number of them if they're everywhere out there on the shell, wouldn't you think? If that's all the early universe, which
That's the Olbers paradox.
Yeah.
oh, well, can we make that a topic some week?
We have before, but we can do it again.
Sure.
Ron, the one thing that I'd say at our parties, there are more stars in the universe by orders of magnitude than there are grains of sand on all of Earth.
Oh yeah, I heard that. That's so hard to imagine.
I mean, that it's hard to wrap your head around that.
It really is. I think we're at the end of the hour. I just have a couple questions of the guys. First of all, Mr. Outreach, Chuck, anything coming up soon that we should know about? That's happening?
What's coming up soon? We
Kachuma.
have Los Flores Ranch Park on Friday.
Oh, yeah.
Okay.
Kachuma again on the Saturday coming up. And then
Okay.
on the Friday after that, Refugio State Beach. And then on the last Saturday, the 30th, Kachuma again.
Well, your Friday should be great watching because that's the new moon, isn't it? That's the switch
Yep.
over.
Right.
And Mr. President, as we get ready to close, your family's on board. Are they watching us today? Did they tune in?
I don't know. They sometimes they send me videos of my grandkid watching me.
Okay.
Oh.
But you said a thank you to Tessa, our outgoing secretary. She wanted, I guess, the talking points. Is she watching us? Should we say hi,
You'd have to
Tessa?
ask her. I don't know.
Well, we'll hear from
We
her.
have two watching on YouTube right now, and one's Astro Deli. So I don't know who is watching on this, but they may end up watching the recordings.
Yeah, they don't
Well,
have to watch in real time.
And we may have our young man in India who's one of us. Well, that's it for the SBAU Astro Hour, everybody. Number 234. Next week, we'll be back again at 11 o'clock in the morning. And in the meantime, check us out online, sbau.org. And don't forget, it's the first Friday of the month we meet at the Museum of Natural History. Can you tell us, Mr. Chuck McPartland, how we say goodbye in this particular land of ours?
Hasta Nebula.
Hasta Nebula, everybody. I love it. Take
Have
care.
a good day.
You
Yep.
too, man.